Wonderful. And would you talk a little bit about your academic journey, your BrainStorm project, and what the BrainStorm process was like, why you liked it, and just give us an idea of what you do?
Yeah, absolutely. So you should know that when I was in high school, I was really puzzled between studying philosophy or mathematics, and then I found out that the cognitive neuroscience was really a way to address philosophical questions with a very strong scientific method. So that's why I moved to Trento to study cognitive psychology and cognitive neuroscience. And well, I found out this amazing research field that is consciousness, which is might be probably the peak of really a philosophical endeavor that is addressed in with hard science method. Um, so I moved to Liege in Belgium to study in the Coma Science Group, and as you stated, there it's basically a group that specializes in disorder of consciousness. So you know, like I really started. I met you through this brainstorm process, and I started this because I really love the idea that brainstorm from the get-go wants to create a project that is approachable for everyone through this speech that is accessible to lay people and people who are just curious. And I think it's very important right now because we should always remember that science is not just for an academic circus, but really for the big public and for the community. So yeah, as you said, like I'm interested in the link between consciousness and then brain complexity. And you know, when I mention consciousness, I'm not alluding to its social or moral interpretation, but it's really in a phenomenological sense, meaning that consciousness is basically synonymous with having an experience. And over the years, there's been more and more literature that has shown that brain complexity and consciousness are tightly linked. So brain complexity refers really to the property of a brain that display varied activity over time and space. And we can really think of it as a brain that's both spatialized, so as a differentiated activity, but is a synergistic, so is integrated in a whole. And brain complexity is high in conscious state, like right now that we're awake, sorry, or when we're gonna go to sleep and dream, and it diminishes, it's low in unconscious state, like deep sleep when there are no dreams or general anesthesia. In a similar fashion, it's low in these states that are known as post-comatose disorder of consciousness, or DOC. So DOC, it's really an umbrella term that refers to really multiple clinical entities. It includes coma, where there is no arousal, no wakefulness, and then refers to unresponsive wakefulness syndrome, what was known before as the vegetative state. That it's a state where basically patients display just reflexes, but not purposeful behavior, not goal-directed behavior, but they're still with eyes open. They display a sleep-wake cycle. But as far as we know, like there might be nothing to live in, there might be no person be behind. And then some patient involved in what's called a minimally conscious state, where is a state where patient display some kind of behavior, like for example, visual pursuit or response to command. And when a patient really is able to communicate or to use functionally an object, then it's considered to emerge from the minimally conscious state that basically a patient that are called the EMCS, and this is not considered disorder of consciousness anymore. Now, what's intriguing is that this patient, as I was telling you, have lower brain complexity than healthy people, and which is particularly true for the responsive wakefulness patients, so the one in the vegetative state. And interestingly enough, for psychedelics are the only drug that reliably boosts brain complexity in healthy participants. When I talk about psychedelics, here I refer to some like a subanesthetic doses of ketamine and psilocybin. And the thing is that if we could give this drug to this patient who have a pathological low brain complexity, and we could increase it to a almost normal level, we could really see an amelioration of their consciousness if brain complexity and consciousness are really so fundamentally linked as we currently think. And so yes, in my PhD, what we tried specifically to do that, we use psychedelics to treat these patients with the hope to have an increase in brain complexity and an increase in their behavioral repertoire. I have to say that I'm trying now to really recapitulate all the things that happened during the PhD, but to be honest, as we were referring before, sometimes when I discuss with people, I just send the video that we made, because it's really is a tool to make all the concepts behind in a very deliverable way that is nice to see, or at least I hope, and that can be accessed by all the ones. So let me thank you. Let me take this opportunity to thank you really for giving me the chance of making the video that now are basically using all the time that I talk about my project.
And I would encourage anybody, I would actually encourage all of you to go to our YouTube channel, or actually just in your YouTube search box, just put in Paolo's name, and his video for Mind Science is the first one that pops up. And it really is a great explanation. It's 6.5 minutes long, and a really great example of how that BrainStorm process, it really forces the person to summarize what they do in less than 7 minutes. So it's a great video. And I wanted to talk or bring up something that you and I had talked about when I was posing questions that I might go over with you. And my question was, can you explain the degrees of consciousness? And I learned from you that there aren't discrete degrees. And so would spectrum of consciousness be a better way to think about it? Or can you help us think about how to understand? You've talked about the different states, but in between those, what's going on there?
So this is a very complex matter that in fact it's currently under heavy debate in the field, because we have the impression that consciousness must be multidimensional and a complex construct, but in reality we have a hard time to define the dimension of the phenomenon itself. I really think that one of the issues, it's because it's so ubiquitous. It's because every time we are here, we are conscious. It's tricky to have a third person perspective of something that is intrinsically a first person one. So there have been some attempts in the clinical context. The way it's often considered, it's through two axes, which are awareness and wakefulness. And really, wakefulness pertains to the simple act of keeping the eyes open, to be aroused, to be able to not falling asleep. Whereas awareness, it's really this more complex construct of a richness of experience of what people are living. And while there's been some consideration of adding, for example, a third axis like connectedness, whether you are connected to your environment, like right now, or not, for example, when you're dreaming, I think that these two alone are pretty good to explain to, like, for example, DOC, because coma is low arousal, no wakefulness, no awareness. Unresponsive wakefulness syndrome, it's really wakefulness without awareness. MCS patient, it's wakefulness with fluctuating awareness. And once we have from the MCS, we really consider that both of them are pretty high. So, I mean, this is really a simplification, but I will say that there is really this discussion of global state of consciousness. And I think this is where most of the focus has been so far, just because it's easier to address rather than looking into local differences, like what's the difference in your phenomenology right now compared to looking at a sea, where in both scenarios you'll be awake and aware what's happening in the world, but your experience will be completely different. And there are some research that go into that direction right now. Actually, a publication just came out from Neuroscience group like last year, but it's really complex. I just want to say, I'm not sure whether we want to dive into this so much, but really there must be a continuum of consciousness in some sense, for a simple thing that we should be able to pinpoint a certain moment during development when we become conscious, and we should have a conscious meter of a way to really scientifically address whether other being animals, computer or plants are conscious or not. And at the moment we are struggling with defining such a tool and such a way to think about consciousness.
Well, my mind is spinning with a lot of questions. So just for example, do you have to have a certain level of awareness to experience like pain? Like, so you were talking in your pitch video about patients in certain states of consciousness that don't respond to pain. And do you know that they're not responding to pain because of some mechanism where you're measuring that, or is it because they can't tell you that hurts? How do you know that it doesn't hurt?
So to go back to the point we had before, it's really problematic to look to something that is so intimate as an experience from an observer perspective. So most of the times, the way we try to understand this, it's through behavior. When it's not possible, we might go into neuroimaging or other brain techniques that can happen. Is it necessary a certain level of awareness to be conscious? I'm not sure. I would say no, meaning that there I lie more on the position that if consciousness is a continuum, awareness might be a continuum. So we might go from saying this is a consciousness that it's so low we do not really consider it to be important, to a certain point where say this is certainly relevant. But it's a tricky point, and pain, it's one of that's mostly considered in the clinical population because we have a duty to reduce pain. So we really should look for painful state in order to really address those and diminish the pain in those patients for their well-being.
Yeah. We could spend hours discussing the nature of consciousness, but I want to focus on the project that your Mind Science funded project. And can you dive a little bit into the protocols and what you're learning? It's been, I think, a year and a half. Are you a year and a half out from doing the work? And what did you find, or what are you finding?
So the protocol in itself, it's it's basically divided in 3 different parts. There is an observational part, experimental one, and there's a follow-up. So the observational one is just where we try to have as many information of the single patient as possible through behavior and neuroimaging techniques, meaning with PET, with fMRI, with EEG. They're just a way to look how the metabolic consumption of the brain, the activity through from magnetic field, and the electrical activity itself. And once we have all this information, what we have then is really an experimental phase that is really the core of the project. And basically what we have two different sessions, and patients undergo both of them. One, it's when they receive ketamine, and the other placebo. Both are given intravenously with an incremental dose, meaning that incremental concentration. We start from zero, and we increment little by little up to a maximum that was previously shown to lead to drowsiness, which is subanesthetic dose of ketamine, basically, in healthy participants. The order is unknown to basically all the team, but one person who does not take part in that acquisition. That's because we don't want to make an expectation during the observation. And what we have, it's a continuous recording of brain activity through EEG and assessment of behavior every 30 minutes. And the reason for that is that if there are signs of consciousness that are visible without reaching the maximal dose, then we would stop without reaching that one, because it will not be necessary. So at the moment, we've been using just EEG because it's really a tricky protocol, because we are checking different things. Just recently, and this is actually something that I don't think I've discussed this with you, we're starting having an evaluation of spasticity, because we observed that there's been a huge decrease in spasticity in some patients during the ketamine session. So we are trying to have an objective measurement besides the qualitative observation of the phenomenon. And but on the long run, we want to start using, as you were saying, non-invasive brain stimulation like TMS, which is a transcranial magnetic stimulation, where we basically perturb the brain, we ping it, and we record the echo of the stimulation through the EEG. And this would allow us to have a very, very strong and defined measure of complexity that we could use afterwards for redefining in a gold standard way what's where complexity was high or low. We want to try something very similar with psilocybin, but there's been so far no experiments with psychedelics in humans in Belgium, so we're still navigating the bureaucratic sea, but we're optimistic to really start soon, finally, to do something close with psilocybin, which is the active principle of magic mushrooms.
Yes.
I
just wanted to jump in, and can you remind us again, or can you review the link between those substances and brain complexity? And since brain complexity is a marker of consciousness, and what is the action of the ketamine and the psilocybin on brain complexity?
So yeah, there's been now a plethora of different results with different techniques that have used both subanesthetic dose of ketamine and psilocybin in healthy participants, and there's been a strong consensus that there is a general increase in brain complexity over with MEG and fMRI specifically. That's been the stronger results. I would say in healthy people, meaning that the level of brain complexity is even higher than the one you would see in normal wakefulness. Interestingly enough, there's been two recent studies, one with ketamine and the other with psilocybin, that look at the TMS-EEG in healthy participants using these two drugs. And for maybe some of the people listening might have heard of the study, there's been basically a dissociation where the complexity measured through just EEG, so through the electrical activity of the brain alone without the perturbation, increases, while the one that is caused by the perturbation, it's relatively stable. So I have to say there is a small increase, but it's not statistically significant. And we actually just sent recently a publication on a paper on that discussed part of these results as well, because it's we might say that there's no crucial increase in complexity, because like the baseline observation, it's already characterized by high complexity, because it's basically wakefulness itself, something that it might not be the case with some of our patients, specifically the one in unresponsive wakefulness syndrome or in a vegetative state.
And going back to something that people might not know, but the TCMS, can you explain what that is?
So TMS, this transcranial magnetic stimulation, it's basically a way to perturb the brain that works through a coil. That it's basically, it's just a wire of an electric wire where a very strong current is passed for a very brief very brief moment, and this is basically like in proximity of the skull, does not touch it, is shielded, so there's no electrical passage of on the skull itself. But what it does, it basically creates a magnetic pulse that, for Faraday's law, induces an electric current in the brain itself. So it's just basically a way to have a huge fire of neurons in one specific location, which is under the coil, without really opening the skull and injecting the current on the cortex itself.
Okay. No, go ahead.
No, I just want to say it's a very interesting technique, because it's very safe. It's been used right for the one who might be curious. It's been used for functional mapping, which is basically a technique for which you basically perturb the brain, and you try to find the region that have a specific function by interfering with it online. So for example, if you're firing in some of the regions that are linked with my language processing, I might have a temporary aphasia where I cannot talk anymore. Why is this interesting? Because this is a way, for example, in the moment when you have to really open the skull and make a surgery, to know beforehand which are the region that you really do not want to touch if you have a surgery. And there's other application as well in psychiatric disorder and other things.
So it can be used as treatment for certain things.
Absolutely, and we actually in the lab we are trying to use it as well as another treatment, but for DFC. But yeah, like yeah, it definitely is. Well, here in this project, it's really used more as a diagnostic tool, as a really neurophysiological marker, rather than that. Yeah.
So I want to switch back to the research that you're doing with your patient subjects. So they are in a state of they're minimally conscious, correct?
So yeah, sorry, actually, I've not even I didn't reply to this question before, but talking about the results we found, I just talk about spasticity because that's the thing that really pops into my mind, because it was just really unexpected. So it's in something I'm really trying to wrap my mind around. But so far we've done handful of patients in both UWS, vegetative state, in MCS, and some even that emerged from the minimally conscious state. And what we observe is that it looks like we have a general increase for brain complexity, but mostly in patients who are already conscious from the starting. Okay. So the effect is pretty good with the EMCS patient. It's not so dramatic with the UWS patients, and unfortunately, we have not seen really a change in behavior. Actually, some patients are look unresponsive during the treatment itself. That is to say that they might have even an increase in complexity, but they show less behavior than before. And we think this might be really a disconnected state of consciousness, again, as the one that we see in really like in dreaming. So on the other hand, we've seen that most of patients have spent more time with eyes open. So it looks like there's an increase of arousal. We are now checking through specific technique whether this is actually the case. It's meaningful or not. And you know, all of these basically results, these preliminary results of increased complexity, no change in behavior, maybe lower, probably better state in spasticity, so decreased spasticity, are now all being merged in one manuscript that we are working on, and we're gonna really submit in the next months.
Oh, that's exciting. So you'll have a publication coming out soon.
Possible, let's see.
Yes.
Finger crossed.
So I want to go back to because I was rewatching your pitch video and was reminded that you had two goals with your project, and one was to, you know, exactly what you're talking about is testing the results that in patients that could actually lead to improved patient care. And so there's that, but then also you're looking at really connecting the level of brain complexity as a marker of consciousness, just in a general sense. And so so has that been, I guess if you'd asked me that question, I would have said, well, it would make sense that brain complexity is related to consciousness, full consciousness. So you're in the process of giving support for that. So because it hasn't been proven yet, or because its answers are still being looked for?
So I would say that at the moment, our results do not strongly support or disprove this link. So I have to say that in this specific case, having negative results might be way more informative than having positive one. With this, I mean, let's imagine for 1 second that we keep seeing what we observe, right? So we keep seeing that there is a higher complexity in some patient, no good change in behavior. Does this mean that the two are independent? Not really, because maybe some of them are just disconnected. Maybe some of these patients, when they wake up and we follow them when we recontact them afterwards and we control how they're doing, one of them might say just, I remember I was conscious. I remember having this crazy experience with some of you. I was just not able to communicate with that. And let's imagine that there is like an increase in complexity and increase in consciousness. That would be very nice. But I think the most dramatic result would be if, for example, there were an increase in consciousness with no change in complexity. Because this would really, really suggest that the two are very much independent. I don't think that's the case, but I mean that's one consequence of this experiment. On the other hand, we could see that sometimes there is an increase in complexity and increase in consciousness, and sometimes no. And in that scenario, that's a really good starting point to look back at the individual patient's data and understand, try to stratify what differentiate the patient who have an increase in complexity to the one that would not. In other words, what's the neurophysiological basis or mechanism that lead to a possible increase in complexity, and the one that's not the case. And this might be important because let's imagine that actually we titrate everything fine. We observe that there is actually, when we give the drug, there is an increase in complexity and an increase in consciousness. If we could find such a biomarker, we might not give the drug and see what happened. We might beforehand look at the patient, look at the brain activity, and see this is a patient who very likely, or not so much, or will have a positive outcome, meaning more behavioral when we give them psychedelics, or it's patients that have a low chances. So we can let. This is really why I was putting up the second point of understanding of physiological basis of psychedelics, of brain complexity, because here in the biomarking, that's really the hint for understanding what's the brain basis for this feature.
Well, this has been wonderful. And I want to, before we go into Q&A, I wanted to also just comment that the work of your lab, we've funded different projects in your lab for many years. But it's all with the goal overall of course, understanding the nature of consciousness. But really, it seems to me that there's a driving impetus or mission really to relieve suffering and to enable families of patients to make more informed choices. So the work that you're doing, in these incremental steps all goes towards making that possible. And do you have a sense, and this might be an impossible question to answer, but do you have a sense of how far that has progressed, that ability and understanding has progressed? And of course, there's more to go, but do you feel like, and again, this might be hard to answer, but are we 10 years away from a full understanding? Or is that like a longer horizon?
So I'm not gonna give any years, but very recently, a professor way smarter than me just lost a bet of 25 years bet with a philosopher. So if it was wrong, I'm not gonna even try to put a number out there. But what I want to say is that so far in the field, there's been a very strong focus on diagnosis, in my opinion, and now there's been a shift in therapeutics, and the two are not so much independent, because we have several proofs that basically being MCS versus UWS, so a minimally conscious state against unresponsive, really have a very strong impact for life expectation, likelihood of responding to the very few treatment that we have, and even with interaction with the people around you. So this is a way to say that even if we have not specifically until very recently focused on a way to decrease suffer of people who have a disorder of consciousness, even just a correct diagnosis has an impact that goes in that direction. Very recently, there's been as well a lot of work about patients who will, like, on the behavior side, they really look unresponsive, but they actually have brain responses or show really conscious-like neurophysiological signatures. So these are people that really are conscious, even if they cannot show it. Very most of the time because of motor problem. So title of this talk is really to treat back to life, and I think that's really an expectation of the whole field. We're really trying to. This is not something about the Coma Science Group. It's really a community effort to decrease the pain and suffering, and to allow these people to really go back to what had or consciousness that's been lost, to basically return to a life that right now might not be.
Thank you so much. That gives us hope. And it's thank you for doing that work. So as we head into Q&A, I'm going to go ahead and we have one here from Susan. Does the nature of the stimulus impact the brain state differently? For example, synthetic drugs versus plant substances like marijuana or mushrooms?
Very good point. As far as I can tell, quite unknown. So let me go straight to one really practical example. When we talk about psilocybin, so basically mushrooms, most of people have studied so far synthetic mushrooms. There's is just as far as I know, one company we're working with which is filament that goes into like a mechanical extraction, meaning that it is not totally synthetic. It's really is based on the plant. Difference of the effects, I don't think there's been any systematic study so far. It's very possible. People suggest that for this really sorry, I'm having a lapsus right now. I cannot recall the actual fact, but like the entourage effect, sorry. So meaning that there's basically, it's not just the single molecule, but even the sister ones that are naturally occurring in the plant that might help the effect of the main one. So far unknown. For different drugs of drugs, so ketamine versus psilocybin versus LSD versus DMT, I would say it would very much differ. I think maybe not in brain complexity itself, but maybe in the path to reach increasing brain complexity, possibly yes, and that's even just because for different pharmacology and affinity of the single substances.
Great. Okay, Vera asks, complexity as a measure or correlate of consciousness. It's interesting. So if you indeed were to find evidence that consciousness is not related to complexity, maybe this would be one piece of evidence regarding AI consciousness. That is, if AI is getting more and more complex, it doesn't necessarily gain consciousness. However, if consciousness is related to complexity, then maybe it's suggesting, absolutely inconclusively, of course, since AI doesn't have a brain per se or body, that AI could become more conscious.
So a very sharp point. I will say, first of all, I'm agnostic on the substrate of consciousness per se, meaning that the thing that the computer are in silico based, it's and not as we are tissue and carbonium. I'm not sure that is enough to disregard any of the consciousness. Let's imagine that an alien came, we have a different completely physiology of us. We should be able to have a measure that checks even if they're not carbon based. However, going to your specific point, I think so far the only theory that has tried to there's been a talk that and has tried to partially reply to on this matter about where higher, like more complex computers might be more conscious has been IIT, which is integrated information theory, and I've seen that very recently there's been there's some work that should show that once you measure complexity, or let's say a measure of if you take the theory seriously, you might prove that most of computers are not conscious, and that's not a function of how many layers there are. So like this, and it's not relevant like how complex, how big they are. They will never be conscious. have to say that within the same theory, there are other small graphs that might be very much conscious, even if we don't think so. So I totally agree with the point of the attendee, and I think that there are some theories that are trying to address that point specifically, and I would look out for new papers soon who might give a hint of to that specific question.
That's what everybody's thinking and talking about right now. And I want to talk a little bit about, what we see in the popular press all the time, mushrooms, psychedelics. And it seems like the popular press has definitely communicated that maybe it's for everybody, or maybe it's, can you talk about how it's like the parameters for when and how and why an individual might make use of psychedelics?
Yeah, so this is a crucial point. I have to say that I'm working with a neurological disease, while most of the attention has been on using psychedelics on psychiatric disorders. And so the two things are different, but of course, most of the hype and of the hope are for psychiatric disorders that we observed so far. I have to say that this is really a personal position, but I'm pretty sure there is like a therapeutic promise, but the psychedelic are not a panacea. So they might not work in all cases, in all individuals, and there have been now some studies trying to define some specific feature of people who might have traumatic experience, challenging experience, like what are basically known as bad trip in everyday language. So I would say that it's very risky when it comes to recreational use, and there are of course concerns about misuse or consumption in uncontrolled settings. And this is the reason why most of people that are pushing for a legalization or like a framework for the drug are really doing so in a way that has a structure. So it should not just be psychedelic. Again, this is really my point, my opinion. It should be really psychedelic assisted therapy. So it's not the drug, it's a journey of well-being, of developing, where there is basically like creation of intention, so like expectation before the experience with psychedelic and afterwards implementation. And it's really the implementation part, like the way, not the drug, it's acting on you, but the way you personally change your life following that experience, that I think it's the most important part. So I have to say, of course, it's not a magical solution. It's a valuable tool, like all these psychedelic things. It's absolutely a valuable tool. I would say that we are still in the early stage of determining what's the best way to integrate them in our society. We're starting to discuss certain setting, politically speaking, even understanding how to construct structure in the health system for psychedelic. It's still not very much discussed. So I think that while anti-psychedelic is absolutely valuable, it shouldn't overshadow basically this evolving nature of scientific exploration. So step by step, we will find out who, when, and how might benefit from these drugs.
Well, and I appreciate, the fact that by the very work you're doing and other scientists are doing is going to lead to determining what kind of tool it can be used as. And I appreciate that you're, what I'm hearing you say is that it's a tool, it's an adjunct to some kind of therapy or some kind of medical treatment, not the focus itself.
Yeah, it shouldn't. Let me just say very, very clearly that, in my opinion, it should not be used as a self-medication. At the same time, I think we're not prepared even to even if I would say it should be done under medical advisor, or like basically a person that is a professional. We still have as a society to understand who this professional is. So this, the doctor is a person with psychology that has a specific training. So it's really evolving right now. This is we are looking at something that is building himself at the moment.
Well, thank you for clarifying and helping us understand the role of and the potential of psychedelics in your work and in mental health settings. But overall, I really appreciate the work that's getting us closer to ameliorating what is one of the most painful and mystifying conditions that an individual and their family can have, which is not being fully conscious. So appreciate what you're doing, and want to see if we have any other questions before we sign off. Okay, we have one here from Susan. I've read that Buddhist monks learn focus through pain experiences. Staying with the pain causes less suffering than trying to distract from pain. Are you aware of similar studies?
I'm not a pain specialist. I would say that, put it that way, somehow it will make sense for a process that is basically habituation, where basically a given stimulus that is given for several time, a certain point does not lead to a response anymore. At the same time, if I think about chronic pain, where there's just a pain that is continuous throughout your day, I don't think that even living through the pain leads to less feeling. So I would say that it's very likely that is dose dependent, how much pain you have, as all the other neural mechanism phenomenon. It's very likely to be time dependent. So how often do you feel it? And I'm really not aware of any study of those, but like if that is interest, I will look for pain habituation and check if what are the studies where feeling continuously the pain continuously in any sort of way leads to less pain. So habituation, pain might be a good two keywords.
So you're distinguishing between chronic pain and, like you said, pain that is time limited and maybe level limited.
Yeah, I'm not sure, but I would say so. Like my intuition is so, but again, this is really from this is not so much from an informed perspective, I have to say. Because like if I think there are even some phenomenon of basically a learner hopelessness, is that the word, hopelessness, where basically when animals suffer from a given pain and they are in no way they are in no position to escape from it after a given time, it is possible that some of those might not escape the pain even if they can. So this is basically a way to say that they are learned that there is no hope. So I really think it's, and my impression is it's really context dependent, but by no way I'm in a position to provide really hint to what this context is. But it's an interesting point and an interesting things to think of.
And I see that Vera, Susan, if you'll look in the chat, Vera has posted a link for something that might give you some more information on that. But pain is definitely a conscious experience. Well, I want to wrap up this afternoon, and once again, thank you, Paolo, for the work that you're doing. Excited to hear how things are a year and a half on, and look forward to seeing your publication. Fingers crossed, as you said. If there's no other questions, I'm going to go ahead and close and just encourage everybody to go to our website and vote for the next Audience Choice Award winner. As Paolo knows, he was the recipient in 2021, and everybody's vote counts. So thank you again, everyone. We appreciate you being here. We'll be back on November 2nd with another webcast on dreams with Karen Konkoly. So we'll see you then. Bye. Thank you.
Bye. Thank you.